with pinhole camera though, you can't make your pinhole camera a kilometer long, right? So
I mean, you can.
you could if you had a lot of time and energy and materials, but let's pretend that we can't do that. One way that we can make it bigger is just simply moving the pinhole camera a little bit closer and extending the back a little bit as well. So instead, let's say I put my pinhole camera right here, and I give it some room at the back. Okay, and I'll just open it up. Since I put it closer, these have to take more aggressive angles, right? When I was further back, my angles were like this. When I move it closer, they're more aggressive angles, which means the image has to be bigger. So it's gonna look like, boom, boom. Okay. So in this case, we'll keep the height of the object as 10 centimeters. We'll say the height of the image,
12.
12, you wanna go? Okay. We'll go height of the image, HI, is equal to 15, or you want 12, I'll go 12. 12 centimeters. There we go. Is everybody good if I erase this part here?
Yeah.
Okay, awesome. So let's do the same thing. Magnification, we put the HI over HO, and we'll plug in our numbers. We've got height of the image at 12 centimeters, and height of the object is 10 centimeters. We'll end up with a magnification of 1.2. As again, it's a ratio, we don't need units. We've got a bigger number, that means our image is greater than our object. Okay? Now, we can do the exact same thing, but with distance. Distance of the object and distance of the image. So let's say, in this case, everybody's got this part down. Okay? And actually, I'll leave it up there for a second, and I'll just go in blue. We're going to use mirrors for this example. So, same thing with my arrow. In this case, when we're using plane mirrors, it's always the exact same. So you know that our magnification with distance of the image over distance of the object is always going to equal 1 with a plane mirror, okay? But let's say this is going to be a little peek into tomorrow. We might have something like this, a curved mirror. It's going to give us a way different image, okay? So let's just pretend that our image is further back. Let's say it's way back here. I'm going to give you that. So we're going to say the distance of the image here to here, so we measure from the mirror, is going to be, we'll go with 10 centimeters, or 20 centimeters this time. Distance of the object equal to 20 centimeters. This one's a little bit further away. I'm going to say this one's equal to 50 centimeters. I'll just leave it for now. So we set it up the exact same. We've got our magnification is equal to 50 centimeters, because this is our DI, over 20 centimeters. What did that give us? It gives us 2.5. Is that what that gives us?
Yes, sir.
2.5, okay? So in this case, would this arrow be this size?
We 2.5.
It'd be 2.5 times bigger than that, right? Your magnification is 2.5. Your arrow would look something like that. And that's not even 2.5 times bigger. It'd be huge though, right? Be further back and it'd be really big. Based on our magnification, okay? the last part I'm going to show you today before we get you working on the worksheet is the big equation that you wrote down. I believe it is
Height of image divided by height of object equals distance of image divided by distance.
height of image over height of object equal to distance of the image over distance of the object.
Yeah.
Awesome. So if you don't have written on your green sheet this equation and these two, I do that. And if you need to write beside it distance of image, distance of object, please do that. I think that will really help because again, equations don't mean anything unless you know what they mean and unless you know how to use them. So let's write them here. Go. So this is the same thing. This is just a ratio, okay? So in a certain, I'm actually going to bring up a question here, and we'll just do it together on the board. Then I'll set you free. Right there. Yeah. Okay. So this is what we were talking about. When the image is greater than 1, it's larger than the object. When it's smaller than 1, it's smaller than the object. So this one says, what is the height of an image or of an object? 8 centimeters. What is the height of an image if an object is 8 centimeters high, is 125 centimeters from a pinhole camera that is 21 centimeters long? And it's kind of a mouthful because they give you 3 different parts of that equation. So how we would set that up, you guys probably can't see over here, can you?
No.
Okay. What I'm going to do then is I'm going to get all this stuff down, I'm going to mute it and I'll bring this up. So we know that our height of object is 8 centimeters. So let's put that in. HO equals 8.0 centimeters. We know our height or distance of our object is 125 meters from the thing, or from the mirror, sorry. And the last piece of information they give us is
21 centimeters long.
21 centimeters long.
And it means it's farther back, so the picture.
What's
will be
21
bigger.
centimeters long? What is the height of an image?
The camera, so like the pinhole that you keep drawing, if you put
Right.
it farther back, it makes a
Right.
bigger.
Okay. Oh, okay, I see what you mean. So our height, or what it's saying is that we've got an object over here that's 8 centimeters high. We've got a pinhole camera that's 125 centimeters away. And then we've got a pinhole camera that is 21 centimeters long. So that's where our image will be. That will be our distance of our image. Okay? 21 centimeters. I'm going to mute this and just show you what that looks like. So I'm going to make this graph a little bit bigger just so that we have everybody on the same page. It gave us an 8 centimeter object, 8 centimeters. From this object, 125 centimeters away, is a pinhole camera. One of these guys. And it told us that our pinhole camera is 21 centimeters long. So we know that our image is going to be right at the back here. It's going to form on the back wall. So our distance of our image from the place where the light enters is 21 centimeters. Okay? Now all we have to do is put it into the equation. So we've got HI over HO equal to DI over DO. We are looking for HI. What do we have to do to this equation to isolate HI, the height of the image?
Put it by itself.
Times by itself, right? Times by the height of the object. I'm just going to do that in different colors so it makes sense. Multiply both sides by HO. By both sides by HO. These can cross off. And our new formula is height of the image is equal to the distance of the image over distance of the object multiplied by the height of the object. Okay? So let's plug this in quickly and see what we get. .21 centimeters is our DI. Got that from up here. Distance of our object is 125 centimeters. And lastly, height of our object, multiply everything by 8.
Do you times both the bottom and the top A, or do you put it in as like times in just the top A?
You could divide first then times it.
Yeah, that's what I do. I divide first then times it, but in all honesty, it doesn't matter which way you do it. You could multiply these together and then divide it all by 125. We'll get the same answer. Because this just means 8 centimeters over 1. That's all that means. Somebody want to plug this in for me and see what we get?
Yeah.
Please start.
1.344.
So, our height of our image is 1.144?
1.344.
344. 344 centimeters, right? So remember our units here.
I thought units didn't matter.
Units don't matter with magnification. They matter with this one because this is all in centimeters or in meters, right? Just make sure you're doing the same one. So we got a tiny little image of the arrow here. That's 1.1 or 1.344 centimeters. How did that feel?
Easy.
Ready to rock? Okay, I'm gonna hand out the sheets then. There'll be a little bit of work with this stuff. And as soon as you're done, we can rock right into independent study, alright?
Can we go to the computer lab again?
I'm not sure, I'll see.